morning, viewers. Let's have a discussion on the instantaneous velocity and the average velocity for class 11 children who are just about to enter their class 11 science stream, right? And for class 11 science stream, the children will be willing to go for physics as one of the optional in the intermediate level. It's very crucial to understand the basic differences between the velocity, instantaneous velocity, average velocity. Like in class 9th, they have discussed all these things, but slightly when they enter to class 11th, they need to understand exactly what is the difference between the instantaneous velocity and the average velocity of a particle, right? So this is what I have tried to make them explain properly the exact difference between the instantaneous velocity and the average velocity. Yeah, we need to understand from the two-dimensional scenario first. Let it be a xy plane and the particle P moves from a point P to P dash. The particle is moving from point P to P dash, and the initial position of the particle is well represented here from O to P as R1 vector, the position vector, right? This is also the new terminology they need to understand in class 11th, the position vector. Similarly, O to P dash will be called as the position vector R2, and R2 minus R1 will be the difference, that is the delta R, that is the displacement of the particle, right? Now the particle is moving in a curvilinear path from P to P dash in a time interval of T2 minus T1 or delta T. Say at P, the time we started was at T1, and at P dash the time is T plus delta T. So the time difference, the difference in the time T plus delta T minus T1, right? Or T1 I can write here. T1 plus delta T minus T1 is your delta T, right? Now at P, at point P, look at the particle started moving with a certain velocity. Now the average velocity, when you ask about what is the average velocity of the particle, then the distance traveled from P to P dash in the form of the displacement. So delta R vector upon delta T will be the average velocity of the particle, right? Or the average velocity we can write as delta x I cap plus delta y j cap plus delta z k cap upon delta t, whole divided by delta t, right? This whole divided by delta t. This can be divided in subparts as delta x upon delta t with I cap plus delta y upon delta t with j cap and delta z upon delta t with k cap, right? So here we need to understand exactly the average velocity of the particle is delta r upon delta t. Now let us ask the basic question of when the average velocity is approaching with the limit of delta t shrinking towards 0, when the time interval of time required for P to P dash is becoming smaller and smaller and smaller, or delta t is approaching towards 0, then we need to understand exactly what will be the average velocity and how it will be changing its definition to the instantaneous velocity. So V bar we are writing here is delta r upon delta t. Now VR is dy dt of x I cap plus y j cap plus z k cap, or dx upon dt with I cap, dy upon dt with j cap, and dz upon dt with k cap, which can be written as v velocity is nothing but x component plus y component plus z component of the velocity. That is why velocity along x component is dx upon dt, velocity along y component is dy upon dt, and velocity along z component is dz upon dt, or the average velocity is delta r upon delta t. Now the befitting question is the instantaneous velocity v of the particle. So when this time will be limiting itself towards 0, that means our position p dash will be shrinking towards p. Once there will be a time, and when the time is very small, infinitely small, that time when it is almost shrinking to p, that time this will be placing itself at the tangent. So when delta t becomes very small, that time whatever small displacement is covered, in that small interval of time delta t would be called as the instantaneous velocity of the particle. So the instantaneous velocity v of the particle is always tangent to the path of the particle. This is very important to understand for class 11 children. Otherwise, in class 9, you have already understood the basics of the distance, the displacement, the speed, and the velocity. And here in class 11th, you need to focus on this common understanding first in few of your initial lessons, such that you will develop the inquisitive mind of how the delta t approaches towards 0 and what happens to our average velocity. It shrinks towards and ultimately it becomes the instantaneous velocity. And this is very important concept to be understood by class 11 children if they are vying to go for the science stream with physics as one major optional. Okay, good day.